Pleasant day to everyone, especially to our professor, Dr. Maria Magdalena J. Bernales. I am Catalina Atup, and my task is to report about the 6 sampling techniques. But before that, let me give you an introduction about sampling techniques. Basically, population consists of all individuals with a particular characteristic that is of interest of the researchers. If data are obtained from all members of the population, then we have a census. If data are obtained from some members of the population, then we have a sample. Researchers use samples to collect data and information about a particular variable from a large population. Using samples saves time and money, and in some cases enables the researchers to get more detailed information about a particular subject. Remember, samples cannot be selected in haphazard ways because the information obtained might be biased. To obtain samples that are unbiased, that is, that give each subject in the population an equally likely chance of being selected, statisticians use basic methods of sampling. Sampling is the process whereby some elements or individuals in the population are selected for a research study. This time, 6 sampling techniques will be discussed. The first sampling technique is what we call random sampling. A random sample is a sample in which all members of the population have an equal chance of being selected. Random samples are selected by using chance methods of random numbers. One such method is to number each subject in the population. Then place numbered cards in a bowl, mix them thoroughly, and select as many cards as needed. The subjects whose numbers are selected constitute the sample. Since it is difficult to mix the cards thoroughly, there is a chance of obtaining a biased sample. For this reason, statisticians use another method of obtaining numbers. They generate random numbers with a computer or calculator. Before the invention of computers, random numbers were obtained from tables. This is an example of a random sampling. Number 2 is the systematic sampling. A systematic sample is a sample obtained by selecting every key number of the population, where key is a counting number. Researchers obtain systematic samples by numbering each subject of the population and then selecting every key subject. For example, suppose there were 2,000 subjects in the population and a sample of 50 subjects were needed. Since 2,000 divided by 50 equals 40, then key equals 40 and every 40th subject will be selected. However, the first subject numbered between 1 and 40 will be selected at random. Suppose subject 12 were the first subject selected, then the sample would consist of the subjects whose numbers were 12, 52, 92, and etc. until 50 subjects were obtained. When using systematic sampling, you must be careful about how the subjects in the population are numbered. This is an example of a systematic sampling. Number 3 is what we call the stratified sampling. A stratified sample is a sample obtained by dividing the population into subgroups or strata according to some characteristics relevant to the study. There can be several subgroups. Then subjects are selected from each subgroup. Samples within the strata should be randomly selected. For example, suppose the president of a 2-year college wants to learn how students feel about a certain issue. Furthermore, the president wishes to see if the opinions of first-year students differ from those of second-year students. The president will randomly select students from each subgroup to use in the sample. This is an example of a stratified sampling. Number 4 is what we call cluster sampling. A cluster sample is obtained by dividing the population into sections or clusters and then selecting one or more clusters and using all members in the clusters as the members of the sample. Here, the population is divided into groups or clusters by some means such as geographic area or schools in a large school district. Then the researcher randomly selects some of these clusters and uses all members of the selected clusters as the subjects of the samples. Suppose a researcher wishes to survey apartment dwellers in a large city. If there are 10 apartment buildings in the city, the researcher can select at random 2 buildings from the 10 and interview all the residents of these buildings. Cluster sampling is used when the population is large or when it involves subjects residing in a large geographic area. This is an example of a cluster sampling. Number 5 is what we call convenience sampling. It is quick and inexpensive because it involves selecting individuals who are readily available at the time of the study. The disadvantage is that convenience samples are generally less representative than random samples. Therefore, results should be interpreted with caution. For example, the researcher may interview subjects entering a local mall to determine the nature of their visit or perhaps what stores they will be patronizing. This sample is probably not representative of the general customers for several reasons. For one thing, it was probably taken at a specific time of day, so not all customers entering the mall have an equal chance of being selected since they were not there when the survey was being conducted. But convenience samples can be representative of the population. If the researcher investigates the characteristics of the population and determines that the sample is representative, then it can be used. Number 6 is what we call quota sampling. Involves the selection of a certain percentage of individuals from specified subgroups of the population when the population is large and list of members are not available. Many polling organizations use this technique. With a quota sampling procedure, we first decide which subgroups of the population interest us. This in turn is dictated by the nature of the problem being investigated or use question being asked. For issues of national interest such as abortion, drug use, or political preference, frequently use subjects are age, race, sex, socioeconomic level, and religion. The intent is to select a sample whose frequency distribution of characteristics reflects that of the population of interest. That's all of my report, and thank you, and God bless us all.